Okay, my name's Ian Cooper, and what I want to talk to you today is about microservices and how I see a lot of people using microservices defaulting to a request-driven architecture, and how that request-driven architecture has problems, and how moving to an event-driven architecture can solve many of those problems for you. This is a little bit about me. It's not particularly interesting. The only two takeaways that I usually ask people to get from this slide are, one, that I don't work for a consultancy. I currently work for a food delivery internet-based service called Just Eat, which skip the dishes in Canada. And so I have nothing to sell you, apart from kind of my experience. But the other point I try and draw attention to is the one at the bottom, which is it can get very easy at conferences to kind of believe that people standing up on raised platforms are the smart people. And we're not really just like you. Just most of us are working people in software. And you could be up here doing what I'm doing. And I understand it requires a little bit of self-confidence to get there. I got here really by accident. When .NET first started in about 2000, 2003, I started a user group. And there was nobody to talk about .NET. There was only really even corporate from Microsoft couldn't send people. So we had to essentially say, who's going to talk next week? Who's going to pick a topic and introduce the whole of the group to this topic in .NET? And that got me through the hurdle of fear of standing up in front of people and speaking, because I had to do it quite a bit. So I'd like to just encourage you that all of you could be standing where I am, and it is really worth it. And one of the things that really helps you do is organize your thoughts about a topic, because you have to essentially be the content. The slides just there to help. And it helps you really dig down into all the edge cases and organize your thoughts. And I'd encourage you all to have a go at speaking. How many .NET developers in the room? Okay, how many Python developers in the room? Okay. So I work on an open source messaging library. We have a .NET version, we have a Python version, and it's designed to help you with connecting to various transports like RabbitMQ, SQS, Kafka. We've only really got an alpha-ish Azure Service Bus, and we'd love to get some help on that. We are very welcoming as an open source community. If you want to come and work on open source, we are really happy to have new helpers, and there's usually quite a lot of work around implementing transports or support for different databases on the platform. We are an alternative to mass transit, which I think is probably better known in the US, and in Service Bus, which is a commercial offering. On the Python side, I guess we're an alternative to Celery. Okay. We also act as an alternative to Mediator in the .NET world, if you want to use that. Right, so what's our agenda today? I'm going to talk about this kind of journey from Monolith to microservices, how we do it. I don't want to labor that point. I'm sure you've all seen a lot of talks about that transition. But what I want to draw out is why we end up in a certain kind of place that leads us to this request-driven architecture. So then I want to really talk about the problem of a request-driven architecture where we end up with really a distributed monolith now, not really a proper microservices architecture. And talk about how people try and throw containers and service meshes at the problem as a solution. And then we'll look at events and talk about how events is actually a better model in many cases. And then we'll talk a little bit actually about reference data. Also, we'll throw in some discussion of pipes and conversations there. They're the bit that I find most people find challenging about moving to an event-driven architecture. There's some stuff there that's not widely talked about enough by people who have experience in event-driven architectures. So sharing that knowledge with you in a few terms will help you go away and dig into them a bit more for yourself. We may have time for questions. Nobody knows. All right. One of the things to point out is that I occasionally in this use examples from an imaginary piece of hotel software. Does anyone here work in hotel software? Awesome, because I don't either, and I know nothing about it. Unfortunately, none of you are any wiser than I am about my lies, so that's all very good. Part of the reason I do it is so that nobody here thinks I'm referring to the mistakes of a previous employer. I can disguise everybody behind that platform. And also, I find that the more I actually know about an area, the harder it is for me to talk about it without getting lost in the detail. So hopefully it's broad enough strokes we can all kind of understand what I'm trying to say. All right. Let's talk about a typical monolith to microservices journey. So there's really one major reason to move towards microservices, and that is because your team has outgrown a kind of 2 pizza size, as Amazon would say. Right? There are now too many of you to work efficiently. Your problem is that essentially, if you have just one large code base with potentially multiple teams working on it, you're going to have to figure out how you can work in the same repo. You're going to have to produce feature branches. When you want to bring those feature branches back into the main line, you're going to have to coordinate whose feature branches are going into this release. Once we've got all the feature branches for this release added together, how are we going to then QA the product with all those features now added into it? Do they conflict with each other? Somebody's feature doesn't seem to work very well in that final testing, so the whole release is stalled. Do we roll that back out effectively, or do we wait for them to finish? And we can't achieve high velocity. We can't achieve this model which says we want continuous delivery. You complete work on a story, and essentially we check it into production as soon as we can. That creates a massive inventory waste, because we've done all this work, but we can't actually get value from it by releasing it to our customers. When the management team come to you and say, we want to go faster, often the solution is to try and say, how can we remove some of this inefficiency from the release process? And so the idea is we break up our platform into a large number of pieces so that each team can essentially release independently of the others. And that's why we tend to be distributed in this model, because it gives each team an isolated piece of the platform that they can release without dependencies on anybody else. Okay. Just to give you an example, Just Eat is about 1,000 people company, and of that, something like 700 are software engineers divided over about 52 teams. Obviously, a problem for us would be if we've got 52 teams working on a single code base, releasing software would be a nightmare. So we try and move towards a model where effectively we divide the software into 52 pieces to give each team the ability to release independently. This is quite often known as the inverse Conway's law maneuver, because Conway's law says that any architecture is a reflection of the structure of the organization that built it. And so if we say, well, what we want to do, therefore, is try and structure our architecture so that we can support our organizational structure, then we actually may get benefit in terms of the velocity and speed that we're moving at. And there are lots of other side benefits we get from microservices. We get a high ability to reason about our software, reduce complexity of what teams individually deal with. But many of those benefits are achievable by simple componentization. Okay? The driving force for us to move to microservices is we have multiple teams cooperating together. And that means something quite interesting, right? We want effectively stable boundaries. Any consumers of the APIs that our microservices produce, we may actually decide that our microservice teams own the front-end components that get gathered together to make up the actual mobile client or the web client. But any consumers of those APIs want a stable contract, right? They want something that's going to remain fairly consistent over time. And when one microservice talks to another, we're also going to want to have relatively stable contracts. We want those APIs to not change every other day, but probably more like, every 6 months or so, we're going to add new items. So we need a way of achieving those stable boundaries. How do we slice up and partition our original large platform into pieces that are stable? So one useful model is called business capabilities. And business capabilities is essentially around the concept of saying, we would like the partitions that our system has to reflect the forces of change that the product team will effectively be driving into our software. What we would like is for any given product manager to be able to say, I need to create some new features around a particular part of what our platform does, and interact probably with one team. Because coordination across multiple teams is hard work. And the typical complaint you get when you start to say, the model I want is to have a team with strong ownership of a given part of the platform, a given microservice, is the product team start complaining and saying it was much easier when I simply got a team of developers given to me to build a feature and they could touch any part of the code base. And the reason they're complaining is because they constantly have to coordinate efforts in multiple teams to get any feature out. But if we get good alignment on our partitions between what the business requires and what the team actually owns, then we may find a greater number of pieces of work can be delivered by one team on their own. For that reason, we look at a thing called business capability mapping. And a business capability is simply a way of breaking up the things that an organization does in order to deliver value to customers. Typically, you can use this modeling to map an entire business and find out its IT needs. In our case, we want to shift the focus of how we do that slightly, probably, to focusing on what our platform, our software platform we're offering does and offers other businesses. Okay? So from, say, Just Eat's perspective, we are building a platform that connects restaurants to customers to delivery partners. And we are essentially offering services to those particular groups of people in order to help them work together. And that's our platform. Those are the services we're offering. So we usually divide business capabilities into 3 kind of levels. You can keep going down. You can go 4, 5, 6. We essentially decompose your business from the top down. So everybody has these things called foundational capabilities that we drive into operational and environmental. So operational are how we actually do stuff for our customers, how we make products and how we ship them to the customers, how we sell them to them. And environmental capabilities are those things that we kind of have to have as a business to support all those functions, like, human resources, for example, or lawyers to talk to the regulators. Now, if we drop down to level 3, which is ignore level 2 for a second, business capabilities are things that we actually offer as services to the customers. Right? Generally, you will find that a mature enough business already knows what the kind of capabilities they have are. So a couple of classic examples. One would be, there's a thing called lead generation. And lead generation is what marketing departments do. And they do that in order to fill basically a funnel for sales teams to go and get basically potential leads that they can phone up or go and visit to sell your products to them. And most salespeople will expect that your marketing department does lead generation. It is a thing. It is fairly consistent that marketing departments do that. So we know that lead generation is a stable idea over time, right? Our marketing, if we're building a platform that does marketing, it's probably going to need to have some part of it which does lead generation. The process by which lead generation is done is unstable. It may change over time. In other words, the implementation of a microservice built about lead generation would change over time as we got better ideas about how to do it. But our platform would always need to be able to offer a lead generation capability. So that gives us a stable boundary to partition on. And it gives us a boundary that the product team would understand, because they'll be able to say, we're building a marketing platform, we're going to need lead generation. Oh, I've got this great new idea. I read an article basically about better ways of doing lead generation. I'd like to implement support for that in our product. One team tends to be dealing with that. If we go back up 1, we get to a capability group. So a capability group is things that have a similar outcome. Okay? And often you'd find in a business that what happens is there is some departmental head who is accountable probably to the board for the delivery of that function. So lead generation typically belongs to marketing. So marketing is probably a capability group, right? Because the results of marketing effectively are to generally generate basically contact with customers from sales. And typically actually what happens is that capability group, marketing and sales, is one capability group, right? Okay. Well, probably not actually. Okay, so as an example, here's my guess of what you might find inside a platform designed to help hotels market their services. So we've got something called rooms, for example. Rooms would deal with basically the booking of rooms, reservations, management of the rooms in our estates, the kind of things that basically say, my hotel consists of a lot of rooms. Sales and marketing would be the bit that sells those rooms to individual customers, right? puts them out on Expedia and says, effectively, okay, please buy my rooms, decides on pricing, organizes promotions. But I've got other services, food and beverage. So we provide basically room service, breakfast, that kind of thing, et cetera, to our customers. We may have some things to do with purchasing and receiving, because we have a lot of stuff going in and out of our hotel, right? And we've got some environmental processes like accounting and potentially legal and compliance. Engineering probably deals with basically maintaining the rooms, and security provides basically make sure the guests are safe, right? It's a guess, right? But you can see the kind of level we're dealing with. And so we can break that down one level, and then we might say, well, in our rooms capability, then what we may well have is some parts of our rooms capability that deal with things like housekeeping, front office, booking, etc. Those kind of things, right? And we can break that down one level again, and we could look at, say, our front office and our reservations. We might divide to say our reservations section is going to get divided up into direct bookings, bookings for large accounts, channel management, which will be about effectively our ability to communicate with, say, Booking.com or Expedia about the availability of rooms that we had for given dates, right? Or essentially front office would deal with the check-in, check-out process. And those are potentially stable boundaries for our microservices. Okay. People often use the word bounded context when they talk about basically dividing up microservices. Bounded contexts are useful. They're a concept from domain modeling, which says, I want to draw up a subset of my domain in which a set of terms have a consistent meaning. So that if I use the word room, I'm going to have a consistent meaning for room in that context. And it's going to have a set of properties that relate to the things that I'm doing with the room. But the problem might be that room is such a generic term in our business that it has many meanings to individual departments. Engineering may feel differently about room to housekeeping to reservations, right? Reservations may care about offering you a king-size bed and a shower and cable or whatever, effectively, whereas engineering may care about what kind of shower got installed in that room, etc. Okay. We can divide our estate up to say, rather than have a room that has 400 properties, in each area we have a room that has the properties that it needs. So that reduces the complexity of our modeling. Generally speaking, a business capability will be at least one bounded context. So we say at least one. It will probably be a domain that is understood by the people working in that area of the business to have certain meaning for terms that they use. Occasionally, you find actually you get multiple domains inside a single capability. Okay. So how do we go about this process of creating microservices? So I've got a monolith, right? And what I do is I've done my partitioning exercise, and I've found what I believe to be my candidate microservices. And then the typical process I use is I essentially say, right, let's take the slice, all the code that deals with that particular capability, and we'll copy it into a new solution or a vector or a new set of folder structure of files that's going to contain basically all of the code that relates to that partition. And that exercise may involve a certain amount of shuffling, right? Because it may not have been a clear slice in my original monolith, a clear vertical slice. And so I may have to essentially juggle a few bits together to try and make a decent vertical slice. And you might end up with, at the same time, thinking, well, I could improve my tests. I could get, some better layering in and get a clean architecture model. There may be a little tiny bit of improvement rather than effectively rewriting. Generally speaking, what you want to do at this point in time, though, is keep the code functionally pretty much the same. Because you're going to be running both this service and the monolith at the same time, talking to the same database. So you want the impact of calling it to have the same effect. And then what you do is you say, right, I'm going to put an API over that microservice. We'll use the term API broad. In most cases, many of you would understand an HTTP API, but any kind of API would do, events and something else, right? And why it's important, we'll come back to later. And what I say is that effectively all the calls that used to go into the monolith now have to be redirected to go through my microservice. And eventually, the only writes to the tables essentially associated with that particular partition will come through my new microservice. The code that essentially is in the original monolith will no longer be writing to those tables. At that point, I can move those tables into my new microservice and say, I now own that data. And typically, I call that point autonomy, because it means I should be able to ship that code on its own. Okay? And you may have to do some work at that point, which we'll come to in a minute, to deal with what happens with pieces of the monolith that wanted to read information from those tables. Okay? And we'll come back to that in a second. But the idea is that nothing in my service now needs to talk to the monolith database. And essentially, we just rinse, lather, and repeat with that process, right? Keep taking slices out until our monolith breaks down, starting quite often with what we might think of as our core capabilities, the most valuable ones that our customers like, the ones that essentially the product team are always basically generating new features for, and work our own way towards the supporting services. And actually, that can take a long time, because the supporting services can be very difficult to finally get over the line, because there's not so much impetus to change them. Okay. Here's where the things tend to start to go wrong in that process. Imagine I've got some code that looks like this. And in my code, essentially, one of the things that originally I did when I took a booking was to make a call to payments to take a payment for the booking. And when I transfer my code into its own little microservice for my bookings service, I come across the problem that I don't have payments code in my microservice anymore. It lives somewhere else in a payments microservice. So in my booking microservice, I'm trying to make a payments call. How do I do that, right? How am I going to make that payment? So we tend to have and reach for a simple answer. And the simple answer is, hey, well, my credit card payment service has got a lovely HTTP API, and I'm going to make a call to that. Or at the same time, I can make a call to housekeeping to tell them about this reservation so that they'll book and get the room ready in time, okay? Or and I'll call channel management so they decrement the count of the number of rooms that are available so we don't overbook the hotel. And that solution seems easy because I'm quite often able to write some simple anti-corruption layer around basically an HTTP call, and I can kind of hide from the programmer the fact that they're doing that in the first place. And they just continue making that self.payments call, and under the hood we're doing this HTTP call, right, by requests or whatever. Okay. We've now introduced some problems that we didn't have with the monolith. The first one of them is called temporal coupling. Temporal coupling is the property that two services need to be available at the same time for something to work. If my channel manager goes down, I now may fail to take the booking, particularly if I've kind of hidden from the software developer the fact that he's actually now making a remote call and just kind of like re-implemented that original local call as looking like something remote using gRPC or whatever. The programmer may be completely unaware that a call to channel manager could fail because channel manager is down and I can't take any bookings. And the question is that what the business really wanted to happen? Were they really so concerned that they might get an overbooking through Expedia? They don't want to take any bookings right now because the channel management is down. Probably not. Generally speaking, if you ask the guys running the hotel what should happen at this point, they'd say, we're okay with overbookings. People don't show up. And if they do show up, we have an arrangement with another hotel down the road that doesn't get as many bookings, and we can put our overflow into that other hotel. So that's fine. If it turned out that the channel manager was down, we could actually have ignored that, guys. Sorry you didn't know that. We missed all those bookings. We lost millions, but what does it matter? Okay. So Just Eat takes something like, I think, 2,000 orders a minute. I don't think this is NDA at all. And when parts of the service are down, it gets very expensive very fast. Right? if we had a dependency on another service between something taking an order and something essentially that basically relates to that order flow, and we said we can't take orders right now because this bit of the system we can't talk to it, you can get into millions of pounds of losses in a very short time window. And we're a publicly traded company, and shareholders ask awkward questions. The other thing we have is called behavioral coupling. So I've got this lovely model that's calling channel management, calling housekeeping, etc. Right? And let's say we're doing really well as a company, and we decide we need to onboard more teams to move faster. And it turns out one of the things that all of our customers want is more housekeeping functionality. I don't know why, but okay. They want more housekeeping functionality. And so we basically hire some more teams, and we say, well, hang on a minute. Help these teams move fast, we're going to have to partition housekeeping. You know what? We're going to go into level 4 rather than level 3, and we're going to decompose housekeeping some more. But the problem now is that direct booking was calling housekeeping, and I've suddenly turned that into cleaning, laundry, and inventory. And the problem with this is that in order to basically release those new services, I'm going to have to tell direct bookings that you're no longer calling housekeeping. You're calling cleaning and laundry and whatever. Okay. And that's kind of a problem because I don't want to have to basically re-release direct bookings and tell that team, you've got to do this whole load of work basically now to support these new services. And we're going to have this grand switchover day when suddenly we're not using housekeeping anymore, we're using these new other services. And don't worry, it'll all be fine. I'm sure we won't lose the platform for any period of time and customers can't book into our hotel. And sometimes these seem like kind of unresolvable problems, but other times we think, well, maybe there are solutions, right? So one of the big solutions today is to throw a service mesh at the problem in terms of temporal coupling, right? So we say, it's okay, we're using HTTP APIs, and we know how the web works. And the web goes to really high scale, right? And the web solves this problem. It just basically uses a kind of proxy model. So effectively, we have a whole load of upstream web versions of instances of channel manager and housekeeping and credit card payments. We stick them behind a proxy, and the proxy basically does some load balancing to all the upstream instances. And then essentially, we can just throw instances at this problem, you know. We can be running hundreds of instances in Amazon, never mind the cost, we're making a lot of money, right? Surely that'll be fine. And we can push basically our requests out to them. And you know what? Seeing as I'm here, there are some advantages I get, right? Now everything's going through a proxy, and I've got the upstream service, I can do health checks. And the health checks will tell me which one of these instances are actually up and running, so I can make sure I direct my direct booking calls to healthy instances of my backend service. I'm really solving the problem now of temporal coupling. And you know what? While I'm here, seeing as I'm going through a proxy, well, maybe it's just a temporary network outage causing me a problem, so my proxy could do a retry. Oh, and hell, you know what happens if basically this thing is really down? I could just do a circuit breaker, and I could say you can't get to that right now. And, well, if I'm going to do all this, maybe I could divide my actual whole thing into a data plane and a control plane, right? And my control plane is going to say, well, I could do some service discovery for you. You're doing basically RPC now, aren't you? So, you know, what the proxy will do is tell you where all the services are. I could do monitoring. It's all thrown through a proxy, so the proxy can be the point at which you monitor what the health of your overall system is. And you can put some configuration here as well, because you don't want to have that in all the individual files, because you know what? That relates to something quite dynamic about the topology of our system. And, you know, at the same time, maybe effectively we can put some policy decisions in here, right? And service meshes are really the way essentially you get workable RPC systems. You know, they're just the same thing as basically a Corba request broker. They got a fancy name because effectively vendors want to sell you the same old stuff with a new name on it. But a service mesh is not new. A service mesh is just a Corba request broker with a fancy new name on the top to make you feel like you're buying something shiny. You've just built essentially 1990s architecture. Congratulations. And part of the problem is when we had this kind of idea of microservices, there was a goal called basically smart endpoints and dumb pipes. How much over time? So brief kind of segue. So microservices comes from a guy called Jim Weber, essentially. And Jim Weber effectively created a thing called Guerrilla SOA. People were doing SOA, and the vendors got their paws in the middle. And they started by making us use things like enterprise service buses, BizTalk, slap-bang. Anyone use BizTalk? Anyone love BizTalk? Okay. And they put these things in the middle of the process, and they made the whole situation very complicated. And Jim just said, you know what? Services are easy. You just basically build an explicit boundary around the work that you're doing, expose some contract that other people can call and go for it. Stick a lightweight broker like Rabbit in the middle if you need a broker, or just do HTTP APIs if you need to, right? The whole idea was to get away from heavy centralized resources controlled by operations teams owned by vendors that locked us into a particular platform. But the vendors don't like that, right? Because we're escaping their clutches. So they're throwing service meshes at us, and they're now trying to rebadge ESBs as event meshes. So what went wrong? Because I still have a distributed monolith, right? I've just got a reliable distributed monolith thanks to my service mesh. And there was a better way, it's just no one told you, probably. Okay. So there's a choice that we're essentially making a lot when we build software, and that's whether we're basically going to favor consistency or availability, right? And originally, the CAP theorem was really focused at databases. And it was focused at the idea that if I had a database supported by multiple nodes, there was a risk that there would be a partition. In other words, the nodes couldn't talk to each other over the network. Generally, they're short outages. But if you run particularly in public infrastructure like the cloud, like AWS or Azure, you see them quite a lot. You see them less on data centers, where effectively your network is about this long. Okay. And the idea is, when there's a network partition, I get one of two choices. I can be consistent. In other words, I shut down the nodes that are in the minority half of the partition. If I've got 3, for example, or one of them is the partition, I shut down that node, let the other 2 continue to give service, because these 2 can remain consistent. They can keep asking each other what the state of the data is now, right? Or availability, I let you access any of the nodes, but we accept that you may be talking to nodes in a stale portion of our network for a period of time. So you're really always choosing between consistency and availability. And with microservices, it's a pretty similar story in a way that if all these microservices are communicating, I kind of get to choose, right? Do I want to enforce consistency? I must be able to get the answer from this other microservice in real time. Or do I want to choose availability? I'm okay with essentially having stale data from that other microservice to service you instead. And events are going to let us do the latter, and I'll explain how in a second. Okay. So the model really comes down to this. When I'm taking my booking, is it important that I can talk to housekeeping? Right? Or can I essentially disregard the fact that I can't talk to housekeeping right now? So my story is effectively that I've had this experience, been checked into a hotel. So I used to, with not my current partner, my ex-wife, used to basically once a year, we'd go to a really fancy hotel for the night, just to kind of live like the other halves did, right? We went to a fancy hotel called the Dorchester, and it's about $500 a night. We turned up, basically, and they said, I'm exceptionally sorry, Mr. and Mrs. Cooper, but your room is not ready. And we're like, oh, paid a lot of money for this room. I wonder what's going on, right? And then they said, please don't worry about it. Go to the bar and drink whatever the expensive alcohols that we have available at the Dorchester are. Just drink as much as you want until your room is ready. It took about 3 or 4 hours for our room to be ready, but you know what? We didn't really care. And so generally there are processes in mature businesses to deal with issues of lack of availability or consistency, right? Particularly if they had a pre-automation process. Amazon does this all the time with you try and buy an item and it turns out it wasn't really in stock. There's a process. They send you an email, right? And actually Amazon quite likes it because that's customer interaction and my chance to offer you some service. And the other option basically is to say I'm going to favor availability. So even if housekeeping is down, I'll just effectively figure out a way to maybe tell housekeeping later. Okay. Doesn't matter right now. When I take your booking, there's no housekeeping service. I'll pick it up with housekeeping later. All right. So a better model is going to be for us to use events at this point to make this change. How does this work? Okay. So what my direct booking service does, when it gets a booking, it raises an event out to a broker like RabbitMQ or Kafka or SQL or SNS rather, or Azure Service Bus. And it raises an event and it publishes it basically to a logical channel. And logical channels you can think of as having like a topic or a name, and we just say, hey, there is a booking made. And other services downstream subscribe to that idea, right? So housekeeping says, yes, I want to subscribe to booking made events, and when I receive one, I will take action, and I will do whatever housekeeping needs to do as a response to that. The advantage of this process is as follows. Let's imagine that Channel Manager is not available. Direct Booking doesn't care. It's just raising its events. It doesn't know whether effectively the Channel Manager is currently working or not. And what happens with events is we basically rely on something called guaranteed delivery. So generally, when we subscribe to a topic, we have a queue. And the queue simply stores up the events for us until the point that we're ready to read them. It's a bit like a kind of an answering machine, right? So Channel Manager basically just takes the events and stacks them up. You can often think about basically, by the way, interactions in terms of services by basically the phone calls, right? I mean, I know no one makes phone calls anymore, but never mind. But once upon a, my mum phones me. But apart from, when you phone someone from the phone, right? If they're not there, it's a frustrated experience. They get a busy tone or whatever, right? I can't call you, I can't make things happen, right? But back in the day, you'd leave a message, right? Hey, you can action this at whatever I'm talking to you about it later. Now we just send a text or whatever, but it's the same principle. And so when Channel Manager comes back online, Channel Manager says, great, I can process those events. Now, it's possibly there's a window in which we got overbooking as a result of that. We are essentially eventually consistent with the booking system, but there's probably a process we have to cope with that. Okay? So provided we think about our business process, we can generally tend to basically support eventual consistency. Okay? And the other advantage is because I'm just raising events, and anyone can subscribe to it. I don't give a damn what the topology of the rest of the system looks like from the point of view of my team. You want to turn housekeeping into a set of different services? Doesn't matter to me. He just needs subscribers. I don't know who's subscribing. I don't really care who's subscribing. Turns out you want to make housekeeping, cleaning, and laundry? You do it. Just release it on your own. Subscribe to my events. Not a problem to me. Okay. So I can break both temporal and behavioral coupling trivially with events. That's what it's there for. Okay. And the price is essentially only that eventually I have to accept some latency. I have to accept what we call eventual consistency. Between these two parts of my system, there may be some lag because I have to process the messages in the queue, or I may be down and come back up again, and I'm coping with that fact by essentially saying, well, you're going to get those messages later. But generally, eventual consistency is a feature of a lot of systems anyway. Even if I'm calling you via HTTP APIs, there is a latency involved, and the data when it leaves your API is stale. Okay, so there are a couple of little things that basically trip people up when they're trying to understand how event-driven architectures work. And so what I wanted to do is cover a few of those to try and help answer some of the most frequent problems that I see. Okay. So the problem is, let's say that when I take a direct booking, it's a booking on account. So rather than being a guest piece of information, where essentially the guest has included all their credit card details, etc., actually it's an account-based booking, and that information is something I've already stored for you, so you don't have to keep adding it every time basically you make a booking with me. So what does credit card payments do right now? Because credit card payments has got a notification that a booking has been made, but it needs the account information in order to actually take your credit card payment. The problem is, if I decide that the answer to that problem is to make a call to accounts, I've pushed myself back into a request-driven architecture. So now, the fact that accounts could be down, temporal coupling, has emerged to bite me again. So all my effort in putting event-driven architecture, the boss is saying, you told me this event-driven architecture thing was going to basically mean we didn't care about other services being down, and now it turns out I can't make direct bookings if the account service is not up for anyone who holds an account. They have to kind of log in via the guest system, and it's really annoying for them to follow that process. Okay. So what can I do to fix this problem? So there are a couple of solutions that we can think about. So down in the lower left-hand side, one thing is simply to include the information with the original message, right? To say, when I basically make a booking and the information goes to credit card payments, I will include all the credit card details, etc. on it, right? It's obvious how to do that for a guest account because they've entered that information. Maybe it's a little bit less obvious how to do that for an existing account. I'll cover that in a second, right? But I can include the information and then you just process the whole booking because you've got all the information contained inside it. The other mechanism is to say, credit card payments has a copy of the account data and it can just read that. And it can read your credit card information straight out of that database. And we might say, but hang on a minute, microservices are supposed to own their own data and no one's supposed to look inside my database. And it's fine, yeah, but this is just a cache. It's a read-only copy of somebody else's data. And again, we'll explain that in a second. All right, so let's dig into these ideas a little bit closer. So one of our first options is to remember that messaging supports a pipes and filters approach. So I can raise my kind of direct booking made, and I can listen to it somewhere else before I pass it to credit card booking. So let's say, in fact, rather than a direct booking made, I just raised instead basically an account booking made. My account booking made essentially doesn't have the credit card information inside it. The account system listens for that. And it says, oh, somebody's made a booking under account. I'm going to need to add the credit card information to that booking so that somebody else can process that downstream. And the account system raises basically then an event to say, hey, I've added the credit card information, so there's now basically a booking made, booking on account made. And credit card payments listens to that event and says, great, I've got the credit card information, and I can essentially process the request. And the whole time I'm moving over events which have guaranteed delivery. So if anything breaks temporarily, it doesn't matter. Because essentially, eventually, I will get to the point of delivering that message to the next person downstream. So I am safe from temporal coupling. Right. I do have a certain amount of coupling in the sense that the message has to flow through a given pipeline. And so essentially, I have some kind of implicit workflow built into this model. All right. Another option is to say, well, rather than build that implicit workflow into basically what we would call choreography between various microservices, maybe I want something to take control of the process of filling in the data so that it goes downstream acceptably. And I'll create something called a conversation. And in our case, probably something called a saga, which essentially says, so a kind of state machine will drive the process of making a booking, and it will run basically the booking through the various steps. And at each step, it will ask a different service to, add data to the message, process the credit card payment, etc. Typically, these are nowadays considered part of the API gateway layer, and they're one of the behaviors that people attribute to things called a BFF, a back-end for front-end. So BFFs tend to be associated more with building an API that's tailored to a given client, but they also can do orchestration for you across your microservices because they expose essentially the booking API, and then effectively you make a series of calls to implement that booking to your individual microservices, allowing your microservices to basically have more limited APIs. So the API gateway can simply say, great, register a direct booking for me, please. Okay, great. And by the way, but using the pipe symbol to indicate this is a message rather than basically a request. I should have made that clearer on the diagram. So there are two pipes because I'm sending a request on one channel and I'm receiving a response on the other channel, right? So with messaging, you can do request response. You just use two channels, right? And generally what tends to happen is when I send the request, I put the reply channel in the header of the request. Please reply to me on this channel. So the command goes out and the receiver says, okay, great, I've got the command in. Oh, I'm going to reply on the channel. Oh, here's a correlation ID maybe, just so you can match the two up if you need to. And then essentially I could call accounts and say, hey, we're going to need the credit card booking details because this one came in on an account. It wasn't basically a guest booking. so I'm going to push it through this route. And probably with the one that's basically a guest booking, I'm pushing it straight to the credit card payments. Okay? So again, it's a request response. I send a request message over a channel. At some point, effectively, what happens is account will respond and send a reply message basically over its response channel. Because I'm using channels that are essentially a queues, it doesn't matter if essentially accounts is down for a period of time, right? Essentially, all that happens is I just wait until account wakes up and then it starts issuing responses back over its response channel. My workflow probably needs to be something I can save to a database so that I can wake it up and say, okay, you've reached the next stage, move your state machine on, and essentially add the credit card information and what's the next step, right? So generally, you use some kind of state machine. So in .NET land, you use something like stateless, or the one from Mass Transit I can never pronounce, auto-autonomous or something like that, effects, etc. Or you can build one yourself, right? Just use a state machine that you can save to a given row in the database. And what happens is you say, send my first event, go to sleep, get the response back, wake up, move it to the next status, send my next event in the workflow, wait for a response. When the response comes in, wake me up, right? And the whole process is asynchronous and doesn't depend on anything being up at any given time, just eventually it works. And the final option then, what happens is basically I essentially send the request for payment to the credit card and get a response back. And obviously the response might include at some point an error if I needed it to. So orchestrators are very good at managing error flows. Okay. Most of you have probably seen those two before. You may not necessarily have understood the use of sagas to basically manage the amount of data that needs to flow through the system. Okay. And the next option is called reference data. From a paper by Pat Helland called Data on the Inside versus Data on the Outside. So when we think about a microservice, there are a number of things to understand about it, right? It essentially has an explicit boundary, like a black hole. Inside of my implementation details, please don't try and reach in and touch those, you're not allowed to, okay? But I, as the owner of the microservice, can change those to my heart's content because I know you're not coupled to them, you don't depend on them. You depend on the API, be that events or basically HTTP or gRPC. That's where your dependency lives, and I guarantee you that will be stable, right? I share schema, not type. In other words, basically, I recognize that I might have a platform that includes .NET, Java, Python, Go, or whatever. So I'm going to share some schema like JSON or Avro or protobuf because they're platform-independent formats. And my service is autonomous. What by that I mean is because I can control all of the interior and you don't depend on it, I can release myself without worrying about impacting anybody else. You don't talk to my database, so I can change the schema, right? Doesn't matter, you're not impacted. You only care about the boundary. By the way, a microservice is a logical definition, not a physical one. A given microservice may be implemented by a number of processes, web process, a worker process, a database, etc., right? Don't confuse the logical idea of a microservice with a physical single process running in your application. Okay. My microservice effectively, though, can be queried. So data does actually leave the event horizon, right? I can do a get, for example, to my HTTP API, and what I'm going to get back is some basically data that represents, for example, a booking, right? And when we do a get, one of the things we may choose to do is say, well, how current is a get that the last data I got from you, right? So when you give me a get, you quite often give me a last modified or an e tag, and you say, this is the current state of this particular resource at this time. And you can also put on your HTTP header, you can put if modified since or if match or an e tag, right? So you can say, do I have the current version of this? And if you do, you get a 304 back. And if you do, if you don't, I'll give you a copy of the new resource, right? So you can cache. You can cache gets locally to your application. And that's how the web scales, by caching, right? I only have one writer of my data. The data that I publish is immutable. There's no point in you trying to change it. You can't change the copy of the data I have inside, right? It's stale. As soon as it leaves my application, it's potentially out of date because somebody else had come in and through my API and post a change to the booking, and the data that you just got 5 seconds ago, potentially out of date. So it's version. That's why we have that if modified since header, right, for example, on it. Okay. And the event's just the same. An event can have a version on it or a timestamp. Tells us how old the data you've received in the event is. Okay. So the data inside our microservice we call inside data. The data outside our microservice we call outside data. Okay. And what I can do is I can simply store that outside data in a local cache to my service. So my credit card payment service can essentially have a cache of data that you've published from the account service about what current accounts are in terms of credit cards, etc., information, and I can then use that to take bookings. Right? It's okay for you to publish that data outside. It's okay for me to cache it. That's how the web works. There are many ways to basically transfer that data. We're going to talk in a second about this one, ECST, Event Carrier State Transfer. But older school technologies include Atom, right? So we get Atom feeds. So basically, it's just I do a get to an HTTP feed, which consists of a number of Atom entries, right? It isn't just for news feeds, right? Each one of those entries can represent essentially the change in the state of an entity in the source system. It was updated, it was deleted, it was a new one was created, right? Atom feeds have a fantastic property, and that's that pages in the feed are immutable beyond the first or current page. So when I ask for that page 13, it's always going to have the same entries on it. That makes it really easy for a consumer to read an Atom feed and catch up, because they simply walk back to the feed until they see until the first page they haven't seen everything on. Find the first entry they haven't seen, and then go back up to the most current entry. So I can effectively, because it's so heavily cached, it's very easy for me to just look for changes that I need to basically apply to my local database. Right? Particularly at the perimeter of your organization, if you deal with partners who need to effectively understand and cache current state of events of your system, Atom feeds are a fantastic solution. ETL, right? I can simply ETL the data between two databases. There are problems with this to do with basically the fact that I'm now coupling schema, and also I need to know it had the same technology on both sides of the fence. But huge numbers of investment banks, particularly in the City of London, have used this approach for years to replicate data throughout the organization that is read-only for one system and was writable for another. Okay? You can even do FTP. Like an FTP data, if it's particularly slow-moving, into a file system. Nowadays, this looks a bit more quite often like writing something basically to a blob storage in S3. Okay? At Just Eat, menu data moves very, very slowly. Restaurants don't change their menus much, so we quite often share it by simply publishing it to S3 as a blob and let people read from there. All right, so Event Carrier State Transfer. Event Carrier State Transfer says the source system may well be producing notifications about state changes to entities it has. If I listen to the events representing the changes to the entity, I can simply update a cache that has my local copy of the entity. So I can use the messaging system, because I get guaranteed delivery, to listen to the messages from upstream and build my own local reference cache. Okay. So now, credit card payments, by listening to upstream messages and writing them to its own database, has a copy of the upstream account data that it can use to process basically credit card payments. Okay. And credit card payments in turn will probably raise events to say, hey, I've taken a credit card payment that another downstream consumer might listen to build its own information about payments made, or booking may use to update effectively its status. Right? So it's just all events. Okay. What that tends to mean is when we talk about our microservice decomposition, we quite often have a model where after we've done cut and shunt and asset capture, where we say, hey, maybe to solve this problem sometimes that we get when we're building microservice breakdowns of what happens to all those tables that I used to call from my booking service that are still in the monolith, I can basically say, well, why don't I force events out of the monolith to represent the state of those tables I used to reach directly into? I can just basically make a cache of them in my system and talk to them there as though they were local to me. And typically we use things like triggers on a database table or scraping an audit trail, and we simulate events being generated out of the monolith and build a cache. So now this process of basically doing the cut and shunt becomes much easier because I have a solution for all the things I used to grab read-only from other parts of the monolith, where before I had to figure out how am I going to get hold of those in the future world while I'm still translating some of these things into new services. While I don't have my complete suite of services, and I'm still reliant on the model having some of the functionality, I can force them into events. I can capture those events downstream. I can have a cache, therefore, of that data, and I can read the data like I always used to. And that helps us basically with an interim step in our transfer of monoliths to microservices. Okay. So reference data is a key part of autonomy. Okay, one last piece. I don't know quite how I'm doing for time. Let's have a quick look. I'm close, good. Right. Okay. The reality is, in some cases, we actually are not so, I can't think of the word, but so determined that we virtually have either requests or events that we say, death to anyone using requests. Reality is most real systems quite often have a hybrid approach between these two. So imagine that when I take a direct booking, I want to take credit card payments, and I also may want to basically, respond to the customer with some offers like, hey, while you're in St. Paul, why don't you basically hire a car? Or why don't you book at our fancy restaurant, the kind of thing that hotels tend to do. And I might say, well, it's really important to me that I complete the payment process and I don't effectively lose your booking. So I'm going to do that by our events, right? I'll raise a direct booking event. I'm skipping potentially putting it through the accounts here. So let's assume it's a guest booking. I've got all the credit card details. I take your credit card payment eventually. If it fails, I'll just raise another event to say it failed and you update the status of the booking. But I want to preserve that. That's going to happen. Okay. But offers, I may not care if offers is down. I may just say, you know what, don't send the customer any offers. The offer service is currently not running. It's not critical to my business. I'm not losing vast amounts of money. I'm losing a little bit probably from some commission I get from the other companies by directing traffic to them. Right? So in that case, because I'm prepared for that particular flow to fail, I'll use a request-driven architecture for it. So usually you're trying to make smart decisions. Any parts of your process that you require to be reliable, in other words, available to the customer, you tend to need to build an event-driven architecture. Any parts of your system where you don't require that reliability, and what actually you may care more about is now consistency, you can build by requests. So Just Eat, for example, is looking at, I think, the idea of saying, according to what the weather is outside, you may change your mind about what food you want to buy, and I may prioritize those differently on a menu, right? So it's a concept I've seen floated around. And that obviously requires some consistency with what's the weather look like right now. Okay. It's no good me saying, well, the weather in the UK is definitely not any good me saying, what's the weather 5 hours ago? Because it's probably different. Over here, I guess your weather may be stable for a longer period of time. But in the UK, it's wait a few hours, you get new weather, right? Okay, so the reality is probably hybrid. But the thing I wanted to really draw to your attention is people are essentially building request-driven architectures as a default for microservices, and you really need events as part of your toolkit. Otherwise, you're going to suffer too heavily from temporal and behavioral coupling to build an effective architecture that gives you the benefits that microservices promised you. All right. So I think it's pretty much time. So I don't have time, I don't think, for particular questions, but feel free to come and find me at the end and ask a question. I will be around in the conference the next couple of days, and I'm more than happy for you to kind of badge me and ask a question. I am iCooper on Twitter, and my DMs are open, so feel free to basically just ping me a DM as well. Okay? All right, thanks so much.